So I'd like to look at rules about polygons here and angles inside of polygons or outside of polygons. There's two that you have to remember. Exterior angles add to 360 degrees. That's the same for every single polygon. And if you want to think about it, well, how many degrees do you have to use to get around a circle back to where you started from? 360. So even if you have like a crazy, nonagon in there, you're still going to go 360 degrees to get back where you started from. So exterior angles will always add to 360. So if we look at one of the examples here, I can see these are exterior angles because they're on the outside of the polygon. And one thing you also want to notice here is that all of these angles are like this shape here is the polygon. And if you're not sure what a polygon is, let me describe that too. A polygon is just any shape with multiple sides. And that includes triangles, squares, rectangles, pentagons, octagons, things like that. So here, that's our polygon, and if you extend one side of it out like a little whisker, you can create an exterior angle. And so again, I'll extend and then create an exterior angle. And you notice each time here I'm going clockwise to make my new angle. So these are all the exterior angles on the polygon. And they will add to 360 degrees. So x will be equal to 360 minus 133 minus 68 minus 90. So here we get 69 degrees, and an abbreviation here could be exterior angle equal 360 polygon, or just poly. That would be your reasoning for it. Now our other rule, the interior, this one can have a little bit of variety depending on the type of polygon that you've got. It's the same rule, but the number that you use here, you'll notice it's sort of an algebraic expression. There's an in it. So the interior angles of a polygon on the inside will add to 180 degrees times n minus 2. And where this comes from is if we look at this, n is the number of sides. So let's write that for ourselves first. N equals the number of sides. So in the shape that they've given us here, to kind of peek at, I can see that I've got 5 sides. 1, 2, 3, 4, 5 sides. And how many triangles do you see inside of that shape? If you try and break it up, you can break that shape up into 3 nice triangles. So what's 5 minus 2? Is equal to 3. And how many triangles did we see? 3 triangles. So that's part of kind of the derivation for where this comes from. But you don't really have to know that if you don't want to. You can just go with the rule and understand that you'll always get the total interior angle if you do 180 times the number of sides minus 2 of them. So in this case, I have a 1, 2, 3, 4-sided shape. So n is equal to 4. So I'm going to go 180 degrees times 4 minus 2. It's 180 degrees times 2, which will get me 360 degrees. So I know that inside of this shape, which happens to be a quadrilateral, because it's got 4 sides, that I'll have 360 total. So x will be equal to 360 minus 82 minus 129 minus 73. And we get 67 degrees. So the trick here is to just make sure that you pay attention to counting up how many sides are on the polygon and plugging that into your formula to first figure out how many degrees are actually inside the polygon. So here you would say interior angles equal 180 bracket n minus 2 on polygon or in polygon. That would be your reasoning for it. So if you have a 5-sided shape, you would put in a 5. If you have a 7-sided shape, you'd put in a 7. And it will give you the total amount of angle space inside. And what you'll find is that the more sides the polygon has, the more degrees you need to get around all the interior angles. And there's a special type of polygon, what we call regular polygons. And this guy here is an example of a regular polygon, where all the sides are the same length, and all the interior and exterior angles then, like all the exterior angles will have the same size, and all the interior angles will also have the same size. So since they're all equal, you just need to think about sharing equally between the angles if you're going to solve it. So for instance, if we want to look at a 5-sided shape, n is equal to 5 for our polygon like we have above, and I want to ask you how many degrees make up each interior angle. Well, first thing I would do is figure out how many angles, or how many degrees total inside of it. So 180 times n minus 2, and because n is equal to 5, I'll do 180 times 5 minus 2. So 180 times 3 is going to give me 540 degrees. And so I know that's my total interior. And so then I need to split that up with the 5 angles that are inside. So I've got 1, 2, 3, 4, 5 angles there. So 540. Split that evenly 5 ways. And what do you get? So you should get 108 degrees for each interior angle. And for the exterior angles, well, we always know the exterior is going to have 360 degrees because it's 360 around any polygon. So I'll divide that by the 5 exterior angles that are there, and you should get 72 degrees. And one thing that you notice here is that 72 and 108 are complementary, they add to 180. So if you go back to your diagram here and we add on an exterior angle, this one will be 72, the one inside will be 108, and together they add up to 180 because they're both on a straight line. So that's something to keep in mind with regular polygons. They will ask quite a lot of questions with that. Just that it's all the same rules for polygons, but just when they're regular, you have the exact same lengths and the exact same angles inside. So use your normal rules, and then just think about sharing the angles equally amongst everything that's in there, whether it's 5 or 7 or 10 sides.